Hey! Get them. We got our calculator mojo on yesterday. Show me you can do it on your own.
Well, I saw her. You guys were trying to.
Why are we not typing yet?
I have no idea why. It says it's sending. Oh, never mind. It just turn on
This was the last extra practice problem in our notes, if you're having trouble seeing it. Clever. Clever is not very. Emily, please tell me you did us all proud and those are the chicken strips. Atta girl. Okay. Their burgers taste funny.
Eat it.
Come on now. I want to know what you know, not what your neighbor knows. Be quiet. Come on, Frank. All right, Pearson's being kind of dumb. Chad, do you mind if I pull your picture up that you had sent? Just because I know someone's going to want to ask that problem. Okay. Okay, I know it's all button pushing, but everyone's going to push buttons a little bit different speed. Were you able or not able to work on anything while you're gone?
I was able to.
Did you?
I did.
Oh, damn, dude.
Well, I
Okay.
got, I don't have all my week 1 through 4 assignments, but I got almost.
The notes is the most important part, so hopefully you can hit the ground running coming in. If not, wander down during Spartan time, we'll get you caught up. Okay. Again, this was that last problem that we didn't get to, or we didn't need to. It seemed like we were doing all right. So rather than come up with something and maybe have numbers that are just stupid, we'll do this instead.
Am I allowed to show her how to make a table since she's using a new calculator today?
Yes.
Oh, that's not there.
It's the same one in your notes if you can't see.
I have a question.
Uh-huh.
Okay, so to find the time, in my notes, I said it has like the maximum. You took the decimal, like
Okay.
of the x value from the maximum. This is minimum. So are you still multiplying it by 60? Or does that change everything?
Pay attention to the table on here. The time is measured in hours. So when it says 0.33, that isn't 1230. That's 0.33 of an hour. So just leave these are just regular decimals. So when you're going to predict the time, you can either leave it as decimal because that's what they did, or you can convert it over to hours, minutes. I will take both. Okay, we've talked in here a couple of times about precedent. If they set the precedent of just staying in decimal of hour, we're allowed to write our answer that way. Yes. Can you round 3 places? Yeah. If you're going hours, minutes, then hours, minutes cut off. If you're saying something point something hours after midnight, 3 places. Yep. See, those are questions of clarification. I'm cool with that on daily quiz. But if we're asking how do I do it, or did I do this right? Well, I can't tell you that. This is supposed to be our gut check.
So wait, but 11, wait, 11, would that be 11 a.m.? Okay, so maybe.
No, that's 11.11 hours. So take 0.11 times 60, it's 11, what, 11:06 and some change seconds. So. All right. It sounds like we got there. We're kind of arguing about the format on the end. Stage 1. I scare the bejesus out of everyone. No, I don't, because that's actually the old graph. Never mind. We were doing multi-polynomial regression in first hour. I thought I still had the big spaghetti monster on here with like quartics and quintics and that. But I guess I don't. Oh well. Come on. Get back over there. Good, Frank. So I'm just going to second plus 7 enter 2 and say fresh start. I got a table full of data. What do I do with it? Yeah. It didn't work. Oh, okay. Stat. Edit. Start typing. 0.33, 3.3, 1111, 3.9. I know we literally live in the geographic center of the country. Like, y'all ever seen the cute little like marble plaque or whatever in Bell? It is literally the geographic center of the country. So we're not anywhere near the coast. Any of you ever actually witnessed the difference in tides? Like, gone on vacation, maybe used to live somewhere on a coastal city. Like, it's something else where you actually watch different times a day. It's like feet of difference. So, anyway, I got to that. Cool, I got data. Now what? Graph it.
Second trace. Minimum. Oh wait, no.
No.
Oh, okay.
No.
We define car.
Oh, wait, there's like a whole step in there. Okay. Stat.
Calculate. Then we have to go 5. And then go to store. Alpha trace.
All right, I'm being facetious, making sure you actually know what you're doing. Okay, so I do the thing. Oh, I had someone from pre-calc ask this, because we've done the regression thing twice now in class, or 3 times? Yeah, 3. So maybe we're getting pretty familiar with this. It had been a while since they had done it with multiple polynomials. If you're on the TI-83, do you know how to store it? Well, I know you do. That's the one you're using. Like, what if you don't have the Bumblebee? Because pre-calc did regression stuff today too. I can't check out 20 calculators to kids to do homework. What happens when you have to do your homework on your laptop and it's on the TI-83 emulator? Do you know how to store it? Okay. It's going to say quadratic regression, blank, 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 and in that spot right after it, that's when you say variables, the y's, the function y1. Okay? So, I got myself a model. Y is 0.600, so cuts off. X squared plus minus 0.622x plus 4.099. Cool. We have model. Use model to predict lowest tide height. Now what? Enter y equals? What? Oh, okay. So I got my function. Second trace. Minimum.
Where goes the window?
Oh, but I can see the minimum. So I actually don't have to. That's pretty nice. 0 to 9. As long as it's pointing in the middle, that's all I care about. I don't care about the guess. Okay. But we have to answer the questions. Use the model to predict the lowest tide height. When does it occur? So the lowest tide height? Tide height. Jesus. Okay, so as happens every year within a week, literally every year, my entire career, within a week of parent-teacher conferences, things are dying outside, allergies, sinus infection. So, I haven't been sleeping like crap. Now that my kids are great, now I got it. So I can't think straight. All I can think about is there's a conga line of dwarves marching back and forth in my nose with feathers on their helmets. 2.488 what? 2.488 tacos? Feet. Is the tide height. Ha. Now, it occurs, you can say either 5.179 hours after midnight, because that was the labeling in the problem. Or take that decimal train, 179, 3068. Take that decimal train times 60. And say approximately 5:11 a.m. Okay? Either one of those will be okay. So, doesn't all of this just fall apart if you accidentally said 3.03? Or you said 46 instead of 4.6? The whole thing just craps out, right? So we're going to say 1 point for did you type them in correctly? Because if that screwed up, it screws everything else up. Did you get the correct quadratic model? Did you get the correct height? The correct time in either format? And one for labels. It's not enough to just say, here's the vertex. The numbers. But you have to tell me what the numbers mean, right? You can't just say numbers. You have to tell me what the numbers mean. So there will be our 5 points. Now, I understand that if you goofed, did anyone goof the typing them in? So the model just, whoof, swing and a miss? Okay. Did you still get quadratic? Did you still find vertex? Did you still label vertex with these things? One off. I want you to remember that, maybe make a note of it for yourself. The next quiz we take is going to have regression stuff on it. So maybe you should write as much as possible on the regression problem so that if I goof just a number, you're not just sitting there with 2 number answers and nothing else. That's the difference between a 4 out of 5 versus a 0 out of 5, because all you have are random numbers and nothing to back it up. What I've seen kids do in the past, just to make sure that they're getting credit, is next to the problem, they'll actually say stat, edit, enter, stat, calculate, quadreg, that. They'll just write that next to their problem, just so it proves they know what they're doing. You just got Homer Simpson fingers. Okay? It's something kids have done in the past. It's gotten them points when otherwise they would have had a full 5 off because there's nothing to back it up. So, just something I'd like to kind of point out. You can go away. Bye-bye. And then, oh yeah, Frank was being dumb. I received a couple of people asked the same question, and it was that number 20-something. There we go. Number 20. More? Okay. They say, what the hell is this? Remember that whenever I have f of x, then there's a rule, and the result is y. So they're saying if I press this x button, I get this y out. This is saying press the -1 button, get a -4. Press the 1 button, get a -2. Press the 2 button, get a -1. If this is the input, that will be the output. So it's just giving you 3 coordinates, but in a different notation than we're used to. That's all it was. And I'm pretty sure I had enough, I think 2 or 3 kids ask that I just sent it out to the whole class. Was that just little blurb enough? Or did we already skip past it? Or figure it out on our own? Okay. How many of us are using the solution manual right now? Using it as it's supposed to?
I checked it for that one.
Oh, no, I sent out a link a while ago. The links on Planbook, since I copy and pasted from last year, they're all old links that go to my personal Google Drive. And they updated the terms of service, so all of those links shut off. So you need to go to the Google Drive link on our webpage before I can go back and fix all of the Planbook links. Yeah, you can still go to like the big Google Drive icon at the top of our page. Just poke that and it'll go to the shared drive on the school server. So I think I sent that out on Remind. I know I sent it to pre-calc. I don't know if I sent it to you.
Yeah.
Oh, okay.
That one got us like a y equals. Y equals like x minus 3 or something. That's what I got from that.
From this?
Yeah. No.
You shouldn't. Any 3 points constitutes a... Oh, determine whether the quadratic model exists. So if I go and plug those in, did it come out as just a line instead of a quadratic? Well, there you go. The quadratic model doesn't exist. It's a linear model.
How do we solve those, like that one and number 10 in the calculator?
Is the equation.
Because we did one problem where we wrote it out, but there was a 0 in it.
X, X, X. List 1, list 2. List 1 is your X's. List 2 is your Y's. Do the regression. That's it. Any 3 points will make a quadratic. Now, the quadratic might not really be quadratic, might end up being a line, but it's kind of like, you remember back in geometry, any 2 points makes a line, any 3 points makes a plane, any 4 points defines a three-dimensional space. Well, 3 coordinates on a two-dimensional plane will define a parabola. It just happened to be a straight parabola this time. So that was the only question I was asked. Everything else go okay? Cool. Then let's do. Oh, I was looking at stuff again last night, and I want to point out again why doing your homework is good. Okay. A, we already know, freshman, oof, right? I went back and I double checked everything in the gradebook. Literally, without exception, every one of those kids has 50% or more of their assignments, notes, and daily quizzes missing. Every one of those kids has done less than half of their work. Every single one. Okay? Just do the thing. Look at the kids who are actually doing what they're supposed to. Look at the kids who aren't. By the power of duh, I shall conclude, maybe I should do my work. Okay? Maybe I should ask questions. Maybe if I'm stuck on something, I should wander down during Spartan time and ask a question. Okay? Yes, sir. I did, but I don't see them back there now. This is 4? Oh, no, I got them right here. Right? Make sure this isn't pre-calc. Yeah.
Thank you.
All right, so we did,
That's what we did.
we just did the first one, right? We didn't make it very far.
So we did the top three and the bottom three.
Yeah, we did all of them.
Okay, so we did all of that. Awesome. All right. Before we go into this, I want the whole lot of you to go to, or wait, this is just to, where are you at? There it is. Womp. Okay. Now, I know it's really tiny, but the front page of your packet of notes has my holy sheet. The holy sheet is a play on words, and it is everything that I have for notes for the chapter. Look at everything that we've done so far. Standard form, here's my vertex, here's my axis of symmetry. Vertex form with all my transformations. Take it further, look at the quadratic stuff that we just did. Stat, edit, this is where they go. Stat, calculate, quadratic regression, store, variables, y variables, function, y1. It's right there. Okay? Over here we have, remember yesterday we had Bubba throwing the lawn dart up in the air? It's specifically called the vertical motion model. Negative 16 t squared. This is always the same because gravity's pull is constant. Initial velocity t, initial height. You can use that to create any model of something thrown up in the air that falls down, or something dropped off of a roof. Now this is the simplistic model. When you go on to physics, you'll start accounting for wind resistance or air resistance. But this is the simplistic model that does it. Below all of that, this is where I'm actually headed with it. Womp. The factoring decision tree. Okay, I know it's really tiny on there. The factoring decision tree is what we're covering today. Meaning every quadratic that I see, the first thing I do, everything to one side of the bus. So when we get to equations, just make sure you put everything on one side equal to 0. Step 1 is always to look for a greatest common factor. So problem 2 says look for common factors. I don't want to factor this as is right now. I'm going to start with a greatest common factor. 6 and 9 have a 3 in common. What else do these two terms have in common? N, right? And if I factor an n out of n squared, I'm left with an n. If I factor an n out of n, well, it's just gone. It's a 1. 6 divided by 3 is 2. 9 divided by 3 is 3. Greatest common factor. Now, I want to be careful with that. What if I had something like 15m squared minus 5m? What do those have in common? I would take a 5 and an m out. When you factor, you're dividing. What is 15m squared divided by 5m? 3m, right? 15 divided by 5, m squared divided by m. What's 5m divided by 5m? 1. And that's something that I see kids goof a lot, is they'll just make it poof. They'll just make it disappear. They'll just write 5m times 3m. When you factor something out, you're dividing. I cannot divide and get 0 unless I have 0 divided by a number. Another important part about this is after you factor, you should be able to distribute and end up back where you started. If I don't have this, is this going to multiply to make this? No. I should be able to distribute this and get right back here. That's how I know I factored it correctly. Okay. What about this one? Okay. So I take a 4 out. X squared plus 5x minus. Now that was the greatest common factor. I'm not done. Because what can I still do with the quadratic after yesterday? Right? What factors of negative 14 add up to a positive 5? Okay. You have to keep going. You can't just stop because, oh, hey, look, I took a 4 out. I'd be like, mom tells you to take out the trash and you just empty out your room. Like, okay, you have to finish the job. So, with these problems, the first thing you're looking for is a greatest common factor. After you take a greatest common factor out, then you look at what's left and determine if you can still factor what's left. Okay? Give it a whirl. You know, I just thought of this. I should have ran them off this morning before class. Does anyone want that old 20 by 20 multiplication chart? Like, would it just help? Like, if you want one? Yeah? I'll print out a couple and try to have them for tomorrow. Sometimes you just brain fart and you can't think of the number. Having that on hand, right? I see a 7 that they have in common. This one, I'm going to say we're done for now. We're going to come back to that one in about 20 minutes. Okay? B. Y'all got 9 in common? Can I factor that quadratic? Factors of -2 that add up to +1. Yep. Okay, you got to keep going if you can keep going. What do they have in common? 4. X squared plus 2x plus 3. What factors of 3 add up to +2? Right? It was a trap. There's no factors of +3. Right? To make a +3, they're both positive or they're both negative. I can't take +1, +3, or -1, -3, and add them together to make a +2. So this one actually isn't factorable anymore. I can only take the 4 out and it's done. Give us a week, week and a half, and then we'll do quadratic formula and complete the square on it. Okay? But right now, it's not factorable. Okay. So, I want to see... Mm, 11D blue. That was our answer in my old calculus class in high school whenever we were just trying to tick off the teacher. Okay, so those 4 problems, I'd like you to factor those quick. I love the shirt. It's like the SpongeBob meme, but an alien. Watch your signs on these. Remember, whenever you get to an answer and you're not sure, you should be able to FOIL and get back to the original problem if you're right. So don't just write something down and say, I'm not sure, maybe. FOIL it. Make sure you're right. You can always distribute and make sure that you're correct.
Or -2 and positive. No. Or hit no.
It's 9 and 7.
-7, 9, and -6. Yeah, 9. There we go. Got it.
I was listening to what he was saying. X plus 9.
Yeah. Like
There we go. Check your work. Argue with your neighbors. Smack them and say, told you I was right. Yes, ma'am. But here's the problem. If I take a -12 times a +2, I make a -24. That's why I chose that one. Because sometimes you have compatible factors that look like they line up, but because of the sign, you have to choose a different pair. Now, I heard a good amount of arguing, so it sounds to me like we know how to do it, but we're arguing about arithmetic. Like, I heard so many arguing about whether it's +9, -7, or -9, +7. I saw several kids over here. I saw several say x minus 12, x plus 2. It does make a -10 in the middle, though, doesn't it?
Yeah, but it does not positive.
But it makes a -24 in the C spot. That's why I chose these, is because these ones all have that little quirk to them where they have compatible numbers as factors that look like they might be right. But how many of us are bothering to check them? Who's checking that this is x squared plus 2x minus 12x minus 24, and then coming back to the problem and saying, oh, you can always check them. There is no reason to get these wrong because you can check them to see if you're right. How many of you knew the 17 and 3 thing off the top of your head?
Well, you didn't know you had 3.
Versus, hell if I know. I don't know. Divide by 2? Nope. Divide by 3? Wait.
Yep.
Oh, dude. Like, that's okay. If you don't know off the top of your head all the factors of a number, you can always just start running through your primes. Speaking of, maybe we should know our primes off the top of our head.
I got you.
Come on.
1, 3, 7. No, 1, 1.
Not 1.
3, 9, 7.
What?
Not 7.
Oh, no.
7, not 9.
No. Y'all are trying to give me squares. Knock it off. Primes.
3 and 7.
2.
3. 7. 23, 29.
31,
So this-
37, 5.
Oh, did I miss a 5? 5, 43,
Yes, sir.
47. Okay. Now, 1 is not a prime because it's special.
It's a.
It is literally called the unit element of multiplication.
Yep.
It has its own special title. It's got a crown and everything. Okay? But if you don't know your primes off the top of your head, you should probably write them down.
Yeah,
Yeah.
you mixed it.
Yeah. I forgot to say 5. Okay. So, if you ever run across a number that you're not sure about, start working with your primes. And if you ever have it hit multiple primes, you also know their multiple is one of the factors. Case in point, what if I said find the factors of 216?
Divided by 2.
Divided by
Do y'all remember factor trees? I heard it was 2 and something.
Oh my goodness. 3 and 9, and then 3 and 2, and then. I mean, 3 and 3.
Dude, I can't remember the last time I did a factor. That was a long time ago.
Okay. But do y'all see how it wasn't just 2s? It was 2s and 3s? So if it's 2s and 3s, that means 6 is also a factor. Okay? So knowing your primes can help you into this to help you find all the other factors, but isn't this something where having that multiplication chart might be handy? Multiplication chart goes out to 20 by 20.
So that's 400.
That's 400. The number 216 is lower than 400. I will probably find factors of 216 on this chart. Okay? Like, honestly, y'all are going to get to it before me. You get to Spartan time, just Google 20 by 20 multiplication chart and print it out. Okay? All right. Now things are going to get goofy. Because everything we've been dealing with so far, look at every one of these. What is the a value?
X squared.
1. Thank you. The a value on every single one of these was 1. That was important because they're all going to break into x minus h, x minus k. They're all going to break into x with number because the only way you're making x squared is x times x. Right? These do not. Now we got something in the a spot.
Yes, no solution. No, it's 11, bro. You just have to have 2x. X.
Well,
It's 2x.
Okay. So what I'm hearing, and this works really nice with prime numbers, the only way that you can make 2x squared is 2x and x. Right? I'm betting most of you, especially given our grade results, are sharp enough to just mental math run through some factors of 12 until you find one that works. But the problem is, when I distribute here, the difference of 1 and 12 versus 12 and 1 are going to result in different middle terms, right? Because this has 2 times 12, 1 times 1, that's 13, versus 2 times 1, 12 times 1. Oh, wait, that's 13 too. Oh, well, maybe that actually worked out okay because it was a 1. Ones do fun things. I might have 2 and 6, 6 and 2, 3 and 4, 4 and 3. You have to check every one of those. Who had a teacher in Algebra 1 that just set it up, guess and check until it works?
I don't know.
Okay. That is like ancient magic right there. Brute force. And I'll tell you honestly, I can't people, but I'm fairly smart. I made it all the way through high school and college, and my first 4 years of teaching doing it just brute force in my head. Because I thought that's how you're supposed to do it. Because my Algebra 1 never even got to quadratics. The first time I saw quadratics was in Algebra 2. Because I went to podunk nowhere and my 8th grade class was 12 kids. I thought this is how you're supposed to do it. What's going to happen when that's not 12? What happens when it's 72? They get disgusting. Okay? So instead, we have an algorithm for this. I want you to look down the tree here. Step 1, greatest common factor. Do they have a greatest common factor? No. Are A and C, first term, last term, both perfect squares? 2 and 12 are not both perfect squares. Does A equal 1? No. And there we go. We have an entire process. It's called the AC method. The AC method says, I'm not looking for what factors of 12 add up to 11. I'm looking for what factors of 24 add up to 11. So what factors of 24 add up to 11? Okay. Step 1. I'm looking for what times what makes 24, but add up to 11. And we said they were what? 8 and 3. So step 2, I'm going to split my b term. 2x squared plus 8x plus 3x plus 12. It's not just called the AC method, it's also called factoring by grouping. Maybe you've heard that one more. Okay? Factoring by grouping, think of it like, who here is the awkward third wheel? Like, these two are all shacked up, right? Like they're doing their thing, and you're kind of you go with them, and then they start making out in the corner of Burger King or whatever, something stupid, right? And you're the awkward third wheel just sitting there. Man, this sucks. Okay. But what if your buddy also brought a friend? Now all of a sudden, these two can go make out over in the corner. We can, even if we don't get along, we can at least talk about how lame they are. We can bash them while they're over in the corner, right? Yeah, it would. That's what the split B is about. I split it because now, instead of having 3 terms and it being awkward, I've got 4. If I have 4, I can factor each half. So these two are hanging out on this side of the ball pit saying, what do we have in common? What do these two have in common? 2, 2x. They have a 2 and an x in common, leaving an x plus 4. What do these two on the other side of the ball pit have in common? So I'll take a positive 3 out, leaving a x plus 4. One more step.
Then you combine like terms. No. I mean,
What if what would I take out of this? What do they have in common? I would take the x out because they both have an x, right? I would write this as 3y plus 4. This is the same thing, it's just uglier. What do they have in common?
4 plus 4.
An entire x plus 4. So I take the entire x plus 4 out. I factor out the common binomial. And when I take a x plus 4 out, look at who's left. 2x plus 3. What?
Did you square that x plus 4?
I do not want to, because if I square this, I take a x out here. I don't call it x squared.
Aren't you taking that 3x?
Remember that when I distribute after this, it has to work.
Okay.
If I take an x plus 4 squared and try to distribute it, now this should say x plus 4 squared. Right? They both had 1, so I take that 1 out. That's it. Done. Now, someone always asks, what if I said 3x plus 8x instead? Okay, I'll show you. I'm going to show you. It's the same thing. What if I came all the way back here, and when I split b, I said 3x, then 8x? These guys got an x in common, leaving a 2x plus 3. These guys got a 4 in common, leaving an 2x plus 3. Now, what do they have in common? Leaving an x plus 4 left over. Okay? These 4 steps. I mean, technically, there's like a step 0 before that says find the GCF. This is called the AC method, or factoring by grouping. I can't factor by grouping if there's only 3 terms. There can't be groups. You can't have a double date with 3 people. What are you doing? The hell are you, a Labrador?
Try to be.
God. Should I give you a Scooby snack when you're done?
Sure.
Okay. So, try it again. Step 1. Is there a greatest common factor?
Yes. Whoa. It's like I like it.
No. Remember, greatest common factor, you're an equal opportunity bully. Just because you can take 4 out of both of these, I can't take 4 out of that. So, I will instead look for A times C and get negative 12. So what times what makes negative 12, but still adds up to B? Negative 6, positive 2?
Yeah.
Okay. So, step 2, split that B term. And the order that you split it in doesn't matter. This is 4x squared minus 6x plus 2x minus 3. Now I'll pause right there. Look at the green line. If I combine like terms, it's still the same quadratic, right? So I'm not changing its value. I'm just rearranging it. Okay? I'm not changing Dawson. I'm just putting him in pants for a change. Okay? Step 3. Factor each half. What do these two got in common? Leaving. I wrote them in this order because I wanted to show you this. What do 2x and negative 3 have in common?
Well, they're both the same.
But they at least have in common a 1. Sometimes you have to put a 1 as a placeholder. Right? 1 times a thing is still the thing. But I need that 1 as a placeholder. And then 2x minus 3. And finally, what do those two have in common now? They both have this, leaving 2x. Now, do you see why I had to put the plus 1 there? Because if I just cut it off there, when I distribute, I don't have a constant term at all. So I need that plus 1 as a placeholder. Again, how do I know that I'm right?
Check.
Say 2x times 2x is 4x squared. 2x times 1 is 2x. Negative 3 times 2x is negative 6x. Negative 3 by 1. Okay, that's how I know that I'm right. Do we really have sophomores in class doing the "he's touching me"?
Yeah, this. Yeah, Kaden. Oh my God.
Yeah, I did. That's what you were doing.
No, I wasn't.
But it wasn't he.
Oh, he's getting all red. Oh.
It's okay, kid. You can get in.
This is cold.
What happens in the parking lot stays in the parking lot, right? Just remember, what happens on school grounds stays on YouTube.
Oh, yeah.
Watch yourself. These two, please.
Oh, we got it. We got it. You got
You two goons both done with these?
You just asked me the dumbest question ever.
We're fine.
Come on now.
just be X plus 1. Yeah, do X plus
Yes, sir.
Yes, sir. Oh. That's just like pretty. I love it.
Excuse me.
Yeah, that was fun.
See, where she's from, 90% of people are polyglots. Over here, we're arrogant Americans. We speak a language. Maybe two if you're lucky. She can insult people however the hell she wants, and no one's gonna know.
There's the 3 times 4. The second one be.
Oh, no. It's bad when you get on.
Now, if you can do this, I'm not going to force you to do it this way. I look at this and I see 3 is a prime number. So I know the only way I'm getting 3 is with a 1 and 3. I also know they're both positive because my middle term is also positive. So now I just have to try to rep through real quick 1 and 4, 4 and 1, 2 and 2. And I try, well, if I have 4 and 1, this will get me 12x plus 1x. Too big. If I try 2 and 2, this will get me 6x and 2x. That's 8x. That's too big. But if I try 1x and 4x, 3 plus 4 is 7. That's how I did it until I was like 25. I didn't know, but what happens when it's not a prime? What happens when that's 4x plus 7x plus 30? Okay? You got to do a lot of more mental steam, right? This AC method, I didn't know this was a thing because I was never taught this in school. I just started playing around with quadratics and proofs one day, and I kind of made it by accident. Went to another math teacher and said, hey, I think I found this algorithm. I think this works for every quadratic. See, look at the formulaic proof. And they looked at me like I was an idiot because they said that's how you're supposed to be teaching it. I had never seen it. Okay? So don't ever feel bad if, wait, why didn't I get it before? Or why wasn't I shown this before? Everyone learns differently. Everyone teaches differently. What I'm going to go for with this is say, what times what makes 12, but add up to 7? I split this into 4x squared plus 4x plus 3x plus 3. Cut it in half. They've got a 4x in common. They've got a 3 in common. Take out the 1 that they have in common. Okay?
What, yes.
All right.
I think
If you're going to intercept, you better run the ball. The other one, B.
Only other one.
Say it with your chest.
That'd be 12, that's a brownie point.
Brownie boy. 12, not negative 12. Still, it's 12 over there too. No.
I think you should fumble into Jacob.
Wow. Yeah, negative 7. Is that class? What's the answer? What?
Negative 4 and negative 3.
Okay, thank you, Ryan.
Have it right in front of you. Oh, I'm gonna
So then,
I mean, no.
break that down into x squared.
Could you go a little slower, please?
I never got to them. Yesterday was hellacious.
8, 6, 1, 4, 2, 8.
Remind me again in another 15 minutes. I'll do them right away at the beginning of Spartan time.
Then those are the same.
Okay.
So cross those out. X minus 2. And then you're left with 2x minus 3.
All right.
That was good.
I know you didn't write the right frequency.
Oh, I didn't see it. My bad.
Maybe you didn't get a brownie point from me though.
Did you actually get it?
Yeah, it's up in the book.
Kid.
Nice.
Yeah. Wait, so if I get to like 5, do I get brownies or how does this?
You have to bring in brownies.
Oh, darn. just go up there. I'll get just keep teaching. It's already taught twice.
You know what? Get him.
I thought you were serious.
I won 32.
It's 11.
But it's not 26, 13.
And then it would just be our course too.
I had a rather rewrite this. So you got.
Calm down.
Oh, what can I add? 10 minutes.
Did you get 5 art plus 13?
I get this stuff. Let's get so excited. Hey, I'm tired. I'm just gonna see us at 8 o'clock. So I woke up at 5 for my lunch. And I'm like tired when I wake up. And I just go to blink my eyes and then boom, I'm out. Just I set an alarm at 5. No, my boy. No, it's 5 hours. 5 hours. Look what he's doing. What do you mean? Did we mess up? Oh, okay.
Okay.
Oh, he did it a different way.
Factors of 130 that add up to 23. Do you see where we might need this method instead of just brute force in the head?
Yes.
Okay. Do you see where you might still have to write out the factors of AC?
Yeah.
If AC gets big enough, you might have to still list the factors in order to find out how to split it. Don't be afraid of writing it out. For some reason, kids just got this irrational fear of writing things, except you, that they're somehow going to end up with carpal tunnel because they wrote some numbers on the side of their paper. You're going to be fine, okay? Just write them out. Just list the factors. Show me thumbs. How we feeling?
Feeling great because they feel good because I talk.
Okay. Hold on. I want to double check something here. I don't trust my mental skills.
Yeah.
Oh.
I just have. I have that.
32 negative 12. I have thrown the mathematical gauntlet. Bring it.
Oh my god! Find the factors of this number. What is it divided by 2? Let me know. Wow. But like, we need numbers that add
How the heck?
I don't know if I like it. Yes.
Well, it's gonna be 12 more, so what's half of 864?
That's what you say, negative 864?
This could be big. Would it be? Oh wait, it's multiplication.
What? What if I just did this? Wait, no, I can't.
Let's see, use it based off.
5R plus 13. Did you get 24? Right? It's 32 times. You're welcome, boys. You're welcome. The first number I did too.
What is that? 900 minus 36 is 30 minus 4 is 26. 226?
Still didn't beat us.
Okay. Now let's say I wanted to just start listing out the factors. These are really, really far apart. They are not going to be 12 units apart. So I should probably jump down to something bigger than that. Maybe I go to 18. Maybe I try 18. So that's 18, 75, 40, 40, 720, 144, 490. It's 5, and another 3 is 8, 48, you said? Okay. Okay. Getting warmer. Those are 30 apart instead of 430 apart. Okay, and you you keep going. What were the magic numbers? Did they rhyme with 36 and 24?
It'd be negative 36.
They've got a 4x in common, leaving a 8x minus 9. They have a 3 in common, leaving a 8x minus 9.
8x minus 9 and 4x plus
Okay, y'all, back up here. The reason I gave you this one is to point out, once you have these two numbers, wasn't it easy? That's the hard part of the problem. The hard part of the problem isn't the actual factoring. It's finding the two numbers. Okay? But it was 8x minus 9 and 4x plus 3. The last thing. Yep. Perfect squares and difference of squares. These are super, super easy, and that's why it's okay that we only have 2 minutes left. Because you notice back on here, we had are A and C perfect squares? If they are perfect squares, whether they have a middle term or not determines whether they're one of these two special forms. Those special forms are based on square roots. What's the square root of 4? What's the square root of 36? It needs to be negative in the middle.
negative. No way.
Which means they come into the form 2x minus 6 squared.
That's what I was thinking.
So what's this one?
8x.
1 plus or minus? Minus, so I can maintain what's in the middle. Okay. We ain't there yet. There's still one more. The other one is called difference of squares. We see the perfect squares again, but what's my middle term? 0. So that's why it's a plus minus pair, so they'll cancel each other out. It's a 5x minus 7 times a 5x plus 7. Because when you distribute now, that 35x and negative 35x will cancel. So 4x there you go. These are special forms. I suggest you take a look at that factor tree, or that factoring decision tree on the holy sheet. Tuesday, Wednesday, Thursday, Friday, Tuesday, Wednesday. It'll be on Wednesday.
So would it be easier for you if I just turned them in by week, like when I have those done? Because I'm almost done with week 2, but I just want to get.
Yeah, just turn them in the next time we do a quiz. Maybe put a sticky note on there so I know this is old stuff.